All right, here we are with section 2.6, Systems of Linear Equations. Before we talk about systems, we need to do a little bit of preliminary stuff about equations in general and solutions of equations, just to get an understanding. So when you talk about an equation like 2x plus 1 equals 5, a solution is the number for x that you can plug in that makes both sides equal. So to find it, you just do the normal stuff, subtract 1 from each side, you get 2x equals 4, divide both sides by 2, you'll get x equals 2. And so that is the number, so that when you do 2 times 2 plus 1, that result will be 5. That's a solution of that equation. If you take any other number for x and you plug it in here, and you do 2 times the other number plus 1, you're not going to get 5. So this just has one solution. Okay, how about if you have a similar thing, but with 2x plus 1 equals y? So when you have two variables here, what happens? Well, you could plug in x equals 2, for example, and is there a value of y that goes with that? In other words, is there an xy solution, an xy ordered pair that when you plug in the x gets you that y, so both sides are equal? And yeah, if you plug in x equals 2, you know that 2 times 2 plus 1 is 5. So that means 2, 5 is a solution of this. What's another one? Well, if you plug in x equals 3, the left side will work out to be 7. So that means the y that goes with that would be 7. So 3, 7 is also a pair of numbers that makes this work. You could also have 4, 9 is another pair of numbers. If you want to plug in something else, like, I don't know, x equals 11.73, or whatever number you want, then the value of y that will make both sides equal is just going to be whatever 2 times 11.73 plus 1 comes out to be. So those are all solutions. So there's an infinite number of values of x you could plug in, and you'll get a corresponding y for each of those. So this has an infinite number of solutions. Okay, so now let's talk about what we mean by a system of equations. So a system of equations is a set of two or more equations. And a solution of the system is a set of values, usually a value of x and a value of y for the variables, that makes each of the equations true. Now, let's look at this example 2 here. When you have 2x plus y equals 5, we know there's an infinite number of xy points, xy ordered pairs, that would make that work. And there's also an infinite number of xy pairs that would make the second one work. But the question is, what is the xy pair that makes both of them, each of them, true? Now there's 3 methods we're going to use for solving a system. Graphing, substitution, and elimination. All right, the first one of these methods we're going to look at is graphing. But first, let's just make sure we know how you can check if something's a solution. So if we're saying xy equals 2, 1, if we want to check if this is a solution of this, we should be able to plug in x equals 2 here, and y equals 1 into each of these equations. So 3 times 2 plus 1 equals 5. Whoops, I got that mixed up. This should be 2 times 2 plus 1 equals 5, and that works because 4 plus 1 is 5. And then 3 times 2 plus 2 times 1, is that equal to 8? Yes, it is. So that means 2, 1 is a solution of the system. And it has to work for both equations, need to both work. Now, to solve this by graphing, you have to graph these two equations. And if you want to do it on your calculator or on Desmos.com, you need to get them so they both have y equals something. Because your calculator, of course, when you go to graph something, that's the form your equation has to be in. So to do that, let's take each of these equations. For this one, I'm just going to subtract 2x from both sides, and that will give you y equals 5 minus 2x. And for the other equation here, I'm going to subtract 3x from both sides, which would give you 2y equals 8 minus 3x. And then you can divide both sides by 2. And here, dividing both sides by 2 means you have to divide the entire right side by 2, which is actually the same as doing 8 divided by 2 minus 3x over 2. And that you could just write as y equals 4 minus 3 over 2x. It's a really common mistake here to just do only the 8 divided by 2 and just get 4 minus 3x. Or just do the 3 over 2 times x and leave the other one as 8. But remember, when you're dividing the whole thing by 2, it's the same as having those two separate fractions, and it works out like so. So that's something you can then graph on your calculator. We can do, over here, I'm going to write it as y equals 5 minus 2x is one of them, and the other one is 4 minus 3 over 2x. And if you graph that, remember what we're looking for is the xy point that makes each of these equations true, or in other words, the xy point that is on the graph of both equations, which is the intersection here. It looks like about 2, 1. We can get it precisely by doing second calc, going down to number 5, or just pressing number 5 for the intersection method. It asks for the first curve, enter second curve, enter, scooch the cursor over close to where it is to make a guess, and it tells you the intersection is 2, 1. All right, so that's how you can do that by graphing. All right, now let's look at the substitution method. The substitution method, let's see what this means. The idea is if you solve this equation for one of the variables, like let's say we solve it for y. What that would mean is getting y by itself on one side, leaving the x as a variable, just subtracting 2x from both sides. That's going to be y equals 5 minus 2x. And by now you might have noticed that this system of equations is the same as the system of equations we had before, which means that we already know what the answer is going to be, but we're trying to learn the method here is the important thing. And because we already have checked that the answer is 2, 1, we don't need to bother checking our answer this time. So anyways, so what is the substitution method? Is once you have one of these equations solved for y, that means that 5 minus 2x and y should be the same thing, which means that the y in the other equation should be also equal to 5 minus 2x. So substitution here means substituting this y with 5 minus 2x. And this is a way of taking the system of two equations with two variables and turning it into one equation with just one variable. So then you can take this and just solve this the normal way. Just distribute the 2 in there, get x by itself on one side, and that will be the value of x that makes both equations true. So anyways, we're going to do 3x plus 10 minus 4x, just distributing the 2 in there. That should be equal to 8 here. 3x minus 4x is going to be negative x. You can also subtract 10 from both sides here, and you'll have negative x equals negative 2. And if you then multiply both sides by negative 1, or divide both sides by negative 1, it's up to you. It means basically the same thing. You'll get x equals 2. And once you know that x is 2, you can then substitute this x in for this x here. And that's going to give you y equals 5 minus 2 times 2, which is 5 minus 4, which is, voila, we get 1. And so that means the solution is x equals 2, y equals 1. And fortunately, I already checked that result up here. We know that's a solution of the system. So yeah, that works. So that's the substitution method, is replacing one of the variables in one equation with an expression that you know is equal to that variable when you're talking about a solution that makes it true. So anyways, let's look at the third method here, which is the elimination method. So with the elimination method, the trick is this works really well when you have something like this situation here. Like you have a plus 5y and a minus 5y in the other equation. Because when you add the left sides of these equations together, and you also add the right sides of these equations together to get a new equation, well, let's see what happens. You're going to get 3x plus 2x is 5x, and 5y minus 5y is 0. And on the other side, you just have 1 plus 9 is 10. So this gives you a straightforward equation with just one variable in it that you can then solve. And really, this is just 5x equals 10. So you can just divide both sides by 5, and you get x equals 2. So that sounds good. Once you have that x, let's just keep going here. And then in a moment, I'll explain why this works. Like, why are you allowed to add these things together? So when you plug in the x equals 2 into, let's say, the x in this equation here, we're going to do another little substitution. That's going to be 3 times 2 plus 5y equals 1. That's 3 times 2 is 6, so I'm going to subtract 6 from both sides. That'll give you 5y equals negative 5. Divide both sides by 5, and you'll get y equals negative 1. So the solution should be 2, negative 1. And again, it's a good idea to replace the x with 2 and replace the y with negative 1 in each of these two equations, just to check that it works. Now's a good time to pause the video and if you want to check that yourself. But I'd also like to take a moment to explain why is it that we're allowed to add the left sides together and the right sides together? Why does that leave you with an equivalent equation with the same solution set as the original system? Well, the idea is, you know, you're allowed to add, like if I wanted to take this first equation and just add 9 to both sides, let's write out what that looks like. You're allowed to add 9 to both sides of any equation, right? That's not going to change the solution set. But if instead of adding 9, if you know for an xy solution that 2x minus 5y is the same thing as 9, then let's just on one side add 9 and on the other side add 2x minus 5y. And you're really adding 9 to both sides. You're basically just substituting this 9 here with what you know is equivalent to it. So you're really adding 9 to both sides, but on one side you're writing the 9 in a different way. And because you're really adding the same thing to both sides of an equation, it leaves you with an equivalent equation with the same solution set. So that's my little explanation for why that works. Okay, now sometimes it's not so easy. This time worked out really nicely when you had the plus 5y and the minus 5y. That just left you with this one simple equation with only x in it. But if we look at example 5 now, if we want to solve this with elimination, it's not gonna, you're not gonna get anything that adds up to 0. Like the 4x plus 3x is just gonna make 7x. Negative 9y plus negative 17y is just gonna make negative 26y. So the thing you can do is make it so one of these either the x coefficients or the y coefficients are the opposites of each other. And I think a easy way to do that, or relatively easy, is just to try to make it like, well, let's see, I can do 3 times 4, which is going to be 12, and you could also get a negative 12 here. I'm just thinking of something that I can get for the 4x and 3x that makes it so they're opposites. So what I'm going to do is I'm going to take both sides of this equation here. Let's multiply both sides by 3. And then take both sides of this equation and multiply it by negative 4. And the idea is that after doing that here, it's going to give you a 12x in the first equation and a negative 12x in the second equation. And distributing the 3 in there and the 4 in here, let's finish this off. We're going to get 3 times negative 9y gives you plus 27y, minus 27y, excuse me. And 3 times negative 17 is negative 51. And then we have negative 4 times negative 17 gives you positive 68y. And then negative 4 times negative 23 is going to be 92. And so that makes it so you can then add these together, and 12x minus 12x is just going to be 0x, which is nice. And then negative 27y plus 68y, those like terms will combine to make 41y, positive 41y. And over here, negative 51 plus 92 is going to make 41. Isn't that nice? So then you can just divide both sides by 41, and you'll get y equals 1. And once you have y equals 1, you can plug that 1 into one of these other equations. Let's say I'm going to replace this y here with 1. So that's going to look like 4x minus 9 times 1 equals negative 17. And so I can just add that 9 to both sides, because 9 times 1 is just 9. And that gives you 4x equals negative 8. Divide both sides by 4. And you'll get x equals negative 2. So yeah, it sounds like the solution is negative 2, 1. So if we want to check that, it's a good idea. Let's do it. We're going to do, 4 times negative 2 minus 9 times 1. Is that equal to negative 17? And if you work it out, you're going to get negative 8 minus 9. That one works. And then let's do 3 times negative 2 minus 17 times 1. Is that equal to negative 23? And that's going to give you negative 6 minus 17. That is negative 23. So that works. That is your solution. All right. So let's do one more of these before you have some exercises to work out on your own. So let's see. If I wanted to do this one with, you could either use substitution or elimination. You should get the same results either way. And so let's see. Maybe, I notice these are written in kind of backwards order. So maybe I want to, I notice there's a 3x and a negative 6y. So if I wanted to use elimination there, I could turn the 3x into a positive 6 by multiplying both sides of this one by 2. that's going to turn this into 6x, positive 6x, minus 8y equals 10. I'm writing it with the x first. And then over here, I'm just going to write this one again, negative 6x plus 8y equals 7. So getting just the same equation that we had here, just written in a different order. So then let's see what happens when we add the left side to the left side and the right side to the right side. 6x minus 6x gives you 0x. And we have negative 8y plus 8y, and we get 0y equals 17 on the other side. So this is saying 0 equals 17. And to solve this equation, we want to know what value of x and y makes both of these equations true. But because these are all operations that lead you to equivalent equations, like it would also make this one true. So we want values of x and y that make 0 equal to 17. But no matter what x and y are, 0 is not 17. This equation is just false for all values of x and y. So that means this has no solution. And what that looks like graphically is if you were going to solve each of these for y in terms of x. I think I can do this in my head here. The first equation is going to turn into y equals 3/4 x minus 5 over 4. And the second equation here is going to turn into y equals 3/4 x plus 7/8 after you solve that one for y. So these are two equations that have the same slope, which is 3/4, but the different y-intercepts. Either negative 5/4 here or 7/8. So what that looks like, if you were going to make a quick and sloppy graph of them, is one has a y-intercept of negative 5/4. That would be this one. The other one has a y-intercept of 7/8. That would be this one. So they have the same slope with different intercepts. That means they're parallel. The lines never intersect, so there is no xy point that is on both equations. All right. So those are the basic methods here, either graphing to see where they intersect, which you can do with your calculator or on Desmos.com. The elimination method, which is what we're doing here, where you try to make the variables cancel out for one pair of variables or the other, or in this case both. And then there's also the substitution method, which the substitution method is convenient when you just have one variable sort of by itself, like the y doesn't have any coefficient on it. That makes it really quick to solve this for y. And then you substitute this expression in for y there. So those are the basic methods. Give them a shot with these exercises, and you can check your answers in the exercises video that is going to be posted right after this.